it's a basic question about whether you want me to just save a word to the location or just skip the location completely.
So if the word is already in the list, you mean?
No, am I just saving words? Am I saving words that are valid to the instant order?
Ooh, that was cool.
If there is a number, do I skip it? For example, I do 12, 14 or 12, 13.
So are you talking about something that's not a word, like something that only has non-letters?
Yes.
So let's get this back. Hello, 1, 2, 3, bye. Okay, so this is word 1. This doesn't exist. This is word 2.
Okay, that answers.
Yeah. Okay, good. And
words with like an apostrophe.
sorry?
Do we include apostrophes?
Apostrophes do not exist.
Okay.
So this is one word, cool stuff.
Okay.
Because the first thing you're going to do is you're going to break things up by spaces. So this is one token, this is another token. You're going to ignore the apostrophe, so that's just one word, cool stuff.
What about like can't? C-A-N apostrophe T.
That's the word C-A-N-T.
Okay.
Right, so the correct treatment would be, and this is not how you want to do it, but the correct treatment would be first go through your input and get rid of anything that's not a letter or a space. Okay, then go through your input again and grab everything that's separated by spaces. And then you're done with the input. Just take those things that you grabbed and now index those.
I was using a delimiter, so I was asking about it.
Okay, but don't do it like that. Don't read through your input twice, but that's the effect of it that you're after.
If done correctly, it filters out apostrophes. Like once it just compiles it into a single word with
Correct.
no apostrophe
Yep, perfect.
on the first try.
Yeah. So other questions or clarifications? All right, let's bring up IntelliJ. A little slow.
Does the A in IDEA mean application?
I don't know. I'm sure it stands for something, but I don't know what. Because I assumed it's a play on IDE and then there's an A that means something, but I don't even know if that's true. So let's close this project. And let's start a new project. And let's call this 223B. Sure, we'll overwrite it. Let's start a totally new project. Come on. All right, so let's make some classes. So I'm going to come down here to source. I'm going to right click and let's make a new Java class. And let's call this circle. So there's a structure for a circle class. And circles are going to have a radius. And an X and a Y center. And I'm going to make a constructor that you can pass the radius. And it's just going to center your circle at 1, 1.
Is that 1, 1?
Yeah, if you take away the stuff that got auto-typed. X center equals Y center equals 1. So there's our whole constructor.
You can do 1 point without adding a 0?
Yeah, 1 point makes it a float, but you don't need something after. You can do 1.0 if you prefer. And let's make a toString method. So when we convert it to a string, it'll say circle of radius blah, centered at whatever X and Y are. And this is just to play with. So let's make a new class. Let's make a main class. So we'll do a new Java class. We'll call this main. There's probably some way that you can do this so it's not dragging around a right brace in front of you while you type everything, but I don't seem to know what that is. So circle C equals new circle. We'll make a circle of radius 5. And we'll just print out C. So we're doing what we could do with Java and Java C and VI, right? We're creating a class and we're creating an instance of it in our main and printing it out and whatever. So we can do that in IntelliJ as easily as we do it anywhere else. So let's build it. I'll hit the hammer to build. And then the first time I want to run it, I don't have a run button, so we go to run and we say run. And it'll ask us what we want to run, and we want to run from our class main. So I'll click that. And it runs, and it says C equals a circle of radius 5, centered at 1, 1. So we've got the same ability that we had with working on the command line. And we've got some added niceties because we've got syntax checking, we've got command line completion, and so on and so forth. So if I misspell the word string, it'll mark it in red, and it'll say cannot resolve symbol. And if I forget one of my brackets, it'll underline this bracket and it'll say identifier expected, which doesn't really help us. But so it's aware of what you're doing. It knows you're working in Java. So that's kind of cool. But the other reason that we want to work in an IDE is because we're going to work with some very large classes. We're going to work with a package called Swing. And Swing is a collection of classes for doing graphical display. Not Swig, Swing. So Swing has all of this stuff in it. It's got things like a J-frame. And you can read all of this, but basically a J-frame is like a container that you can put other things into, but it's a visible container. It's a box. Every window that you see on your system is something like a J-frame. And it usually has buttons for maximizing or closing in the upper corner, and it's got a title bar, and you can right-click and get a context menu and stuff like that. And a J-frame, Java frame, is a general frame, which is a type of window, which is a container, which is a component, which is an object. There's a hierarchy of classes sometimes, which we have to talk about when we talk about extending classes.
And Swing is a class that contains this?
Swing is a package, basically. It's a collection of classes that contain all of this stuff. And it's built on top of something called AWT, that's the Abstract Windowing Toolkit. That's a low-level set of classes for manipulating graphic displays and such, for drawing things. But it's very low level. It takes a lot of work to put up something like this with like colored bars going across and the dark blue on the top and so on. Swing does a lot of stuff for us and makes it very easy to create things like windows. So let's close this project out and let's create a new project. Did that signature sheet make it around? Who's got the signature sheet? Okay, I just want to make sure it gets around again for people who came in late. So let's call this Swing Demo. And so I'm going to expand this so I have a source directory. I'm going to right click on there. I'm going to say new, but instead of saying Java class, I'm going to say Dialog. Okay, so click on that, and it's going to let me create a dialog. What should my dialog be called? I don't know, I'll just call it main again. And it says, do you want to create a main method? I'm going to say yes. It's also going to generate OK and cancel buttons. I don't really care about those, so I'm going to uncheck those. And when I say OK, I've got code. Right? It's created some lines of code here that for the most part we're not going to have to worry about too much what this does. But this is code that will use things like JPanel and JButton. These are part of Swing, to create something that we can look at, something visual that we can interact with. So before we do anything else, let's run this code. So I'll say run, let's run main. And it makes this little window up here. And I can resize it, and it's got a pair of buttons that don't do anything. And there's a context menu there, and I can click this to maximize, and I can click the X to close it. And when it closes, it says process finished.
It's somewhat like Zenity.
It's somewhat like Zenity, but it's going to be a whole lot more flexible. It's also going to take a little more work to get things to pop up, but things like IDE will do IntelliJ will do most of the work for us. Okay, so when we're working with dialogues, we have a pair of tabs up here. We have our Java code, that's main.java. There's also a tab main.form. That's a visual representation of what our window is going to look like. So here you can see the two buttons. And this is a spring, this is a horizontal spacer that basically controls what happens to these buttons when the window grows. So if I run this, there's my window. If I make it bigger, you notice the buttons are pushed over to the right. That's because I basically have a spring over here pushing them as far to the right as possible. If I do this, and I run this, now my buttons are growing, and one is anchored to the left and one is anchored to the right.
How are you manipulating this?
Manipulating this? So this is all drag and drop, right? I can just move these things around. But here's the thing. There's something called an absolute layout, which basically says if you put a button here, that's where the button's going to appear when your code runs. If you put a text area here for typing in, that's where it's going to appear when the program runs. There's no such thing apparently as an absolute layout in IntelliJ. You can't just place your components and have them appear exactly there. You're forced to use what's called a layout manager. And the layout manager does intelligent placement of your objects as the window is resized. Okay, this is considered a feature. But it means that if we want to place things very precisely, we have to understand what the layout manager is doing for us. So we're not going to worry about that yet. The default layout manager is pretty straightforward to work with, but it takes some work. So for now, we're not going to worry too much about precisely placing these components.
The IntelliJ version that they use for the Android Studio, when I worked with it, it's like almost the exact same thing, except they make it a hardline error that unless you add every possible constraint for it to
Right.
intelligently place buttons, it will not let you compile.
Yeah, yeah.
So that's like kind of how they get around the fact that if you just let it intelligently decide it, like, will probably screw up. Is they
Right.
say you have to give us everything, or
Okay.
you won't even compile it.
Yeah, and it's considered good form to, like, you know, take charge for what happens when the window gets resized. And especially on a phone app, you have different size screens, so that's always going to be an issue. But sometimes it's nice to have it quick and dirty, just put the buttons and that's where they appear. And as far as I know, nobody has made an absolute layout for IntelliJ. So I'm going to delete these things and get rid of this and that and that and that, and hopefully not break anything.
It's up there in the corner.
And it's up there in the corner. All right, that's what I was hoping for. So we've got just a tiny little window with absolutely nothing going on.
How fun.
How fun. And the code for it is pretty simple. It's still got our OK button for some reason, but that's okay. All right, so what can we do with forms? Well, over here you have a palette of different kinds of things that you can put onto your dialog. So there's a panel. A panel is kind of like a holding area for other things. So I could take 5 buttons and put them in a panel, and then if I move the panel around, all those buttons get moved along with it. So it's sort of a area. Scroll panes are similar, but we can put scroll bars on the side. Buttons are fun to mess with, so I'm just going to left click on the button, right? And I'm not holding the mouse button now, but if I move this over here, it will drop a button wherever I click. So I can go left, top, top right, bottom, middle, and so on. So let's put a button right here. So there's button. And if I run this, I get a box and it says button. And the button doesn't do anything. Okay, so back in here I can click on this button, and over here I have a set of properties. So the field name is button 1, that's what it's called internally. The background color is specified by this, 242, 242, 242. If I click on this, I can select the background, so let's go with this. And now if I run this, oh boo, that's not what I wanted to have happen. It worked earlier. Oh, there's the background. Alright, so I needed to change to another entry before it took. So I got a colored button. I can change the text color by setting the foreground. So we can make the text annoying yellow. And we can set the text. Right now it says button. We can change this to you can't read this. And there's all kinds of things that you can set, including you can set expert properties, and then you've got other things that you can control. But these are highly customizable, right? If you want to display an image in the background of the button, you can take a file with an image in it, and you can say use this to fill in the background. So you can have textured buttons or whatever. And you can have shadows and all kinds of things. There you go. All right, so we'd like to be able to do something when we click the button, because that's what buttons are for. So let's talk about two versions of programming, two styles of programs. Most of the programs that we've written so far in 224, 222, so far in this course, 121, 120, and most of what we did in 270 are all the same style of program, which is we have a sequence of instructions that say do this, do this, do this. When you get here, go back up here and do this again. Test some condition and either do this or that. Right? So it's a very sort of sequential operation. And in particular, the program is always doing something. There's always a next instruction that's going to be executed unless the program has just exited. And if it's exited, then it's done. But other than that, there's always a next instruction that's going to do something. There's a different way to write programs, and it's the way that most modern programs are written. It's the way that operating systems are written. And consider, for example, what's going on this window right now. So up here in the upper right, it's hard to see, but there's something that says 76%. That's my battery level indicator. And that's slowly going up because my laptop's plugged in. So at some point that'll change to 77. How does that change to 77? Is there a piece of code running which says check the battery level, convert it to an integer %, and display it up there? You could do that, right? But that's something that's got to happen constantly. Simultaneously, there's a temperature in the upper left, there's a date, and there's a time. And I could have code that says check the time, display it up there, check the temperature, display it up there, check the weather, it's cloudy, display a little cloud up there, right? And also, it could say, see if the mouse is moving. Get the XY coordinates of the mouse and display a little pointer there. And check the mouse buttons. And if the right button is clicked and your mouse pointer is sitting at the name of something here, display this drop-down list. And if the mouse pointer passes one of these items that's not grayed out, change the background from gray to blue and change the text from black to white. Okay, that's a lot of work. And there's all this stuff that can be done. Everything here is responsive. And the number of if statements you would have to write would be ridiculous. And so that's not how operating systems are made. All of this stuff is what we call event-driven. It's responsive to events occurring somewhere. So there's no set of code which is saying, check the mouse position, see if it's equal to such, and if it is, draw a blue line right here. Instead, there's a piece of code which said, hey, when the mouse moves, let me know. Wake me up and tell me what the new mouse position is. And the code that drew this drop-down menu said to the system, hey, I want to know about mouse events. I want to know when the mouse moves. And so the mouse moves, and the operating system taps on the shoulder of this code and says, hey, the mouse has moved, here's the new XY position. And the code can look at that and say, okay, thanks. And then you come down here and it taps the shoulder of the code and says, hey, here's the new XY position. And the code says, ah, okay, the mouse is over the paste. I need to redraw that with a blue bar, and I need to draw paste in white letters instead of black. And then when you left click, this has also been asked to be notified about it. And it'll get a message saying, hey, someone just left clicked. And it can look and say, oh, you were sitting on the paste and you just left clicked. Okay, I'm going to do the paste operation. And it runs the method corresponding to pasting, whatever that does. So this is all about two things. One, registering requests to be told when events happen. And then when the event actually happens, whoever asked to be told gets told. So how do you register a request for an event to occur? You basically talk to the system, whatever system is monitoring all of this stuff, and you say, when this type of event occurs, execute this code, make a call to this method, and pass me some arguments maybe that tell me about the event. So if you want to know when a mouse moves, you could say, okay, here's the name of my program. I want you to call this function when the mouse moves, and I want you to pass it arguments that tell me what the new mouse position is and whether any buttons are pressed. And now you can go off and do whatever you want. You can play games, you can just sit there and say loop, jump to loop, right? And when somebody moves the mouse, bingo, you're going to jump to this piece of code. It's going to execute to see whatever it has to do, take care of it, and then go back to wherever you were. So what does this sound like? It sounds like some other concept from 270. Sounds like interrupts, right? This is what interrupt-driven code does. This is just software interrupts. But it's the same idea. You sort of pause what you're doing, you make a function call to some other set of code, it does its thing, and then it returns, and you're back to where you were. So what's happening when nothing is going on? What is the system doing? It's probably doing this. Or in assembly language. It's really just spinning its wheels. So everything is event driven. So let's tie an event to this button. So I'm going to right click on the button and I'm going to say create a listener. A listener is a thing that is asked to be told when some event occurs. So let's create a listener, and we have different kinds of listeners we can create. Okay, we're going to start with an action listener. The action of a button is to press it, to click it. So we'll create something that listens for this type of event. And the only action choice that we have is action performed. Okay, the button's been pressed. So we'll say OK, and it creates some code. So you can't read button, that's the name of the button. And we're running a method on there called addActionListener, and we can put some code in here. And we're going to print out a message saying the button has been clicked. And I'm going to keep track of how many times we've clicked the button just for kicks. So I'm going to have an integer called count, which will tell me how many times the button's been clicked. And when the button is clicked, we'll increment count by 1, and we'll print out the button has been clicked, and the number of times was count. So let's run this. So there's our button, and we click it, and it says button has been clicked, number of times 1. And I can keep clicking this, and it's going to keep count of how many times I click the button. So now we got code running in response to events on this graphical interface. And that's all you need, right? You know how to write Java code, you know how to do things. This is what lets you tie it in with GUIs, interfaces. And so you can do whatever you want at that point. All right, let's look at how this happens. So you can't read button is the name of a J button. And it called it that because that was what I set the text to. So I set the text to you can't read this, and it changed the name of the button to you can't read button. So that's a J button. Well, what is a J button? So it's an element in Java X swing. A J button is a type of abstract button, which is a type of component, which is a container, which is a component, which is an object. And it has a number of methods available to it. But it also has methods from the fact that a J button is, for example, an abstract button. Well, an abstract button has all of these methods available to it. And so add action listener is something we can do with a J button, and what does it do? It adds an action listener. Well, that's not a very useful description, but that's what it does. So add action listener is a method that's available inside a J button. So you can't read button is a J button, and I'm saying let's add an action listener. So what is the argument that I'm passing to add action listener? The first question, how many arguments am I passing to this? Because it's a method. How many arguments am I passing?
One.
How many?
One.
One. What's the argument?
New action listener.
Is that it? So here's a parenthesis. This is the beginning of my parameter list. Where's the closing parenthesis that matches that?
At the end parentheses by the curly brace.
Yeah, down here. So all of this,
It's like a catch.
yeah, all of that is my one argument to this method. And what is this? This is a declaration of a method called action listener. Right? It's constructing a new action listener, and it's describing a set of code, and all of that's going in as an argument to this method called add action listener. So this is a tricky thing you can do in Java. We could write a separate action listener, and then we could use the name of that in the argument list to add action listener, but you can actually specify it in here right away. And we don't need to think about that too hard because this interface will write this for us. All right, but if we were doing this from the command line, we'd have to know that we had to type all of that in, and so on and so forth. But we don't have to think too hard about it. All right.
This sounds extremely powerful.
It is extremely powerful. I'm going to try something here. I have not tried this before.
I wonder what set modal does.
Yeah, that's what I was afraid of.
Set modal is even important in the security.
So a modal dialog is a dialog that you can't ignore. And basically your code's going to sort of get stuck until that dialog disappears. I'm not thrilled that this has to be modal. There's probably a way to change it, so don't worry about it for now. All right, let's go back to the form. Let's look at other actions. So let's say create listener. What are some of the other actions we can perform? Focus listener, and this will tell us when we gain or lose focus. So in a window, there's always a component that has focus, meaning that if you were to type, your keystrokes go into that window. So you may have a text area, and if you click on it and you start typing, your text appears in there. And usually when you click on something that gets focused, it changes appearance slightly. If it's a button, sometimes you see a little dashed box around the text showing you focus. Well, we can say when you gain or lose focus, I want you to let me know. So if we were to add a focus listener, we have the options focus gained, focus lost. And we can create code that gets executed when any of those events happen. We can create a listener for a key event. And we can say when something happens related to key presses, I want you to let me know. We can create mouse listeners when you press buttons. We can create a mouse motion listener when the mouse moves. We can create a mouse wheel listener when you scroll the mouse wheel. So we can create lots of different events, lots of different things that we want to have trigger a call to our code. So let's make a text field. And I'll make a, it's not going to let me. Okay, that's fine. So here's a text field. Let's put some text in it, like type here. And let's put some listeners in. So we'll create a listener. Let's do focus listener. So let's see what happens when we gain focus. So we'll just print a message saying we just got the focus, and let's create a listener for focus lost. And we'll say we lost focus. So here's our text area. We've got focus right now, right? So anything I type in here is going to appear in here. If I click somewhere else, like down here, it loses focus. If I click in here, it gains focus. So we could do something, right? And I can hit tabs to move around my widgets. So when I tab, it gains focus. When I tab again, the button has focus, so the text area loses it. So we could respond to that if we wanted. Let's do a text area. And let's do some mouse listeners. So let's do a mouse motion listener. So mouse dragged means you're moving the mouse with a button held. Mouse moved means you're just moving the mouse pointer. So let's make a mouse moved listener. And we'll just say mouse is moving. Now let's make this big. So there's a click, and every time I move the mouse, I'm getting a mouse move event.
It's a lot of
Yeah, there's a lot of events happening here, and it's hard to see because
mouse moving is happening a lot.
yeah. So let's see how much is happening. Let's use our count variable and see how many mouse events we're getting. Oh, it didn't like something.
Your machine counts semicolon.
Thank you. Yeah. All right, so here we go. So not a ridiculous number, but pretty fast. Right, from there to there, it's picking up a few dozen mouse events. So if I move less than a pixel, it's not going to register as an event. If I move 1 pixel, it will definitely generate an event. But if I move, a few hundred pixels, it's not necessarily going to generate 100 events, because this is not instantaneous, right? Everything's taking time. But after it comes back and it goes back to monitoring the mouse position, if the mouse is moving at that point, it'll make another call to our handler, and so on. Well, so we can tell when events happen, but it would also be nice to actually know more about the event itself. So this method that we're working with, add mouse motion listener, new mouse motion adapter, inside there's a method called mouse moved, and it takes an argument called mouse event. And mouse event is an object of type mouse event. And we can read this, but we won't. Mouse event has some constants, right? Some integer values. And it's got some methods like get location on screen, get point, get X, get Y, get button. So if a button's held or pressed, we can tell that. So let's just do something pretty straightforward. Let's just print out the value of mouse event. So when I move in here, right, all of this stuff after the number that we're printing out is the two-string results of mouse event. And this is all the information that's available that we could get from the mouse event. For example, it's a type, Java AWT event, mouse event. Mouse moved, it's giving us a pair of coordinates which look like coordinates relative to this text field, because up here, that first set of coordinates is close to 0, 0. But it's also giving us coordinates labeled absolute. Those are screen coordinates, so we can tell where we are on the entire display. And it's telling us the text area and some information about the text area, and there's stuff that goes beyond here, right? So lots of information available. Where'd my window go? There it is. Bam. So let's be a little more nuanced. All right, so when we get a mouse event, I'm going to print out x equals. I'm going to call mouse events get x method. And then I'll say y equals, and I'll call mouse events get y method. And if we run this, now we're just picking up x, y coordinates. Now if I click and hold the button, we're not getting mouse events because these are mouse dragged events, not mouse motion events. But if I release the button, these are back to mouse motion. If we wanted to know about drag events, we could also say create a listener for mouse drag events. So all of this comes down to basically designing whatever kind of interface you want with whatever widgets you want, right? Checkboxes, labels, text areas, and so on and so forth. And then creating code that you want to respond to different events with. And so the first challenge is just sort of familiarizing yourself with the scope of possibilities, right? What kinds of widgets, what types of events. And then you get to do the fun part, which is the creative part, which is, okay, so I want to make a tic-tac-toe game, that's PA3, how am I going to put these things together so that I have a cool kind of interactive tic-tac-toe game that on a touch screen, you can just touch and it fills in your square and so on and so forth. And all of this is handled by the JVM, right? So now I have my touch screen turned off. But if I turn my touch screen on, right? Oh, my touch screen is on. Okay. So I can just move my finger around and generate mouse events. Or I can click on the button with my finger, right? And am I using a mouse? Am I using a touch screen? Am I using my touchpad? That's all handled for you by the JVM. Your code doesn't have to change just because there's a different type of input device. If I put a tablet with a pen into this, right, and I start using that, the code's going to work the same. So there's this layer in between the hardware and your Java code. That's the AWT, and it's Swing in particular. That takes care of that bridge. So this is where it starts to get fun. Okay, this is where we can sort of spend our energies more on the design part instead of the minutia. But we'll still spend some time on the minutia. All right. So tomorrow will be an open lab. So if you want to come in and play with IntelliJ or work on PA2 or whatever, I will be here both morning and afternoon sections. I'm not lecturing new material, so if you don't have such needs, you don't have to come. I'm not taking attendance tomorrow. All right, so I'll see you tomorrow or Friday. Thank you.